Today, we're going to look at something pretty incredible, how some of the most advanced AI is being used to save some of our most ancient history. We're diving into a PhD thesis that shows a brand new way to read centuries-old Tamil manuscripts before they literally turn to dust. And that right there, that's the heart of the problem. You have to imagine entire libraries of knowledge, of history, literature, culture, written on these incredibly fragile palm leaves hundreds and hundreds of years ago. And right now, they're just fading away. These aren't just old papers, they're irreplaceable pieces of our past. And honestly, we're in a race against time to save them. So let's get into it. Why is saving these texts so unbelievably difficult? I mean, it's not just that they're old. The real challenge is in the very fabric of the manuscripts themselves, which have been just ravaged by time. On one hand, you have the dream scenario, what a scholar hopes to find. Clear, crisp characters on a nice, clean leaf. But the reality, that's what researchers are actually dealing with. We're talking about faded text, leaves that are damaged and discolored, and just centuries of wear and tear that have created this noisy, almost unreadable mess. Just trying to figure this out with your own eyes is a monumental task. So let's break down these challenges, right? First off, you've got the physical decay. The leaves are literally falling apart. Then you've got all this background noise, things like stains and smudges that cover up the characters. When you try to scan them, you get uneven lighting, which creates all these dark and light patches. And to top it all off, the ancient Tamil script itself changed over the centuries. So you can't just teach an AI one style. It has to learn a whole timeline of different writing variations. It's a huge challenge. But this is where technology steps in and offers a really cool solution. The research we're looking at here proposes something called a deep fused neural architecture. Now, that sounds complicated, but you can just think of it as a super powerful, multi-stage digital restoration toolkit built specifically to solve this exact problem. And the whole process is actually incredibly logical. It all starts with a basic digital cleanup, just to improve the raw image. Then it moves into two really critical stages, binarization and super resolution, and we'll talk about those in a sec. It's only after the text is made as clear as humanly, or I guess as digitally possible, that the final AI model tries to actually recognize the characters. Each step is perfectly designed to make the next one's job a whole lot easier. Okay, so that first key step is called binarization. The goal here is pretty simple. Teach the computer to see the ink and just ignore everything else, the stains, the cracks, the noise. To do this, the thesis uses a model called a ResUnet, which is really good at looking at an image and seeing both the big picture and the tiniest details all at once. It basically learns to tell the difference between the shapes of the characters and all that random background damage. This step is absolutely crucial for making the unreadable readable. All right, next up is super resolution. So even after you've cleaned the image, some of the characters are still going to be faint or blurry. This is where something called a GAN-based architecture comes in. Think of it as two AIs working together. One AI tries to intelligently sharpen the characters, making them look better, and the second AI acts like a critic, judging its work until the result looks like a real, high-resolution character. It's kind of like having a digital forger and an art critic working together to perfectly reconstruct information that was almost lost forever. So, the big question is, does all this high-tech theory actually work in the real world? Well, the results are genuinely impressive. And this really says it all. When you put the accuracy of the older methods head-to-head with this new fused model, well, it's not even a contest. The difference is a massive leap forward. It just proves that tackling this problem with one integrated end-to-end approach is way more effective at cutting through all that noise and decay. And that is the bottom line here. This whole pipeline managed to achieve a character recognition accuracy of up to 95%. That stunning level of accuracy means that so many more characters, more words, and more sentences from these ancient texts can finally be recovered and actually understood. So what is it that makes this research a true breakthrough? Because it's not just about one clever algorithm. It's about the entire approach and what it means for the future of preserving history. What makes this so unique is really two things. First, you've got the deep fused architecture itself, this idea of having a single, powerful tool that does both the restoration and the recognition. But just as important is the data. The researchers actually built a custom dataset of Tamil manuscripts from different centuries. An AI is only as good as the data you train it on, and this unique library is now a vital resource for pushing this kind of technology even further. And this brings us to why this really matters in the real world. This isn't just an academic exercise in a lab. This technology is a direct tool for preserving our shared cultural heritage. It means we can digitize entire archives, making them searchable for scholars and accessible to everyone. And ultimately, it ensures that this ancient knowledge isn't lost to time, but is instead passed on to future generations. And that leaves us with a really powerful final thought. This research has basically created a key to unlock a very specific piece of our past. But as this technology gets better and better, it just makes you wonder, what other locked doors are out there? What other fading texts and lost histories from all around the world are just waiting for the right digital tool to bring their voices back to life?